Except that anyone have doubt, we can ask. But let's wait 1-2 minutes more, then we'll start uh, the summary thing. Let's people join. That would be good. If anyone have doubt, please let me know from anywhere. Hope everything is going well. Uh, uh, week 3 is done. There is one error in week 3. An answer. Don't worry, that would be in the evaluation will. We are actually seeing that, and no need to worry for that. Yes, Tripti,
Yes.
what's your doubt?
Sorry, in this lecture, what we will do?
In this session, we'll try to do a summary.
Summary of week 4.
Yes, summary for week 4.
Okay, sir. Thank you.
So I have a doubt in mock test question 11 and 12.
I have a doubt in week 3 practice assignment.
Yes, sir. I have also doubt in mock test of mathematics.
Okay. Okay, so let's discuss this. Let's the people join some more. Then we'll start the summary thing. That would not take much time. 10 minutes we can spend on discussing the doubt.
Okay, sir.
Okay, so let me present my screen. My screen is visible to all of you.
Yes, sir.
Okay, so mock, deadline for mock is over, no?
Yes.
So which question number 50?
So I
Sir,
have
12 or 11.
11.
week
Yes.
3 practice assignment.
No, Tripti have some mock doubt first. She said. Which question number 50? 11 and 12.
So this is Tripti. I have a doubt in week 3 practice assignment. There is just
Okay.
silly doubt.
Week 3 practice.
So in question number 7,
Okay.
option 3,
Mhm.
like we have an equation, right? For maximum x, value is -3, and at -3, the value of y is -1. So the maximum value of the above function is -1. Isn't this correct?
The maximum value of the function is -1. So, but for that function, in this option is asking that means giving information that maximum value of the function is -1. So it's just finding the axis of symmetry and value of that at that point.
Yeah, that's right, sir. That is -1. Here in the fourth option, it is given that slope at the function -3, -1 is 0. That option is correct, but the third option is wrong.
Okay.
How is that so?
The function is fx is equal to x square 6x plus 8 plus 6x plus 8. So symmetry will be x is equal to minus b b6 upon 2a, which is what. So this is going to be -3. So maximum value will be at the axis of symmetry. So value of the function at -3, this is 9 plus -18 plus 8. So yes, you are getting -1. Right? The value at -3 is -1.
So, but the answer key, it is not in a correct answer.
Okay. No, so the reason is, see, this is asking for maximum value, and this is A is our positive, no? A is not negative. If A is positive, what is going to be in that case? How the parabola will be? Upward and down or
So
downward?
this function gives the minimum value, not a
Okay.
maximum value.
How it will be?
Out of A is greater
It
than
will
zero.
be, yeah. So whatever the root will be, the roots is -2 and -6. That means 2 and -6 would be. So here
Yes,
is,
sir.
it will be like this.
Sorry, sir. I got it.
Yeah, it is -1 here.
Thank you, sir.
Yeah, somebody will doubt. What's
Sir,
your doubt?
mock test question number 5.
Maybe also have some doubt. Question number 5. What's your doubt here? Hello, am I audible? What's your doubt?
I'm don't I'm don't recognize this question.
You are not getting this question.
Yes, sir. I'm not getting the question.
Okay, so a study conducted at a factory conducted at a factory manufacturing chemical. That factory is uh, just
Sir, your voice is not audible.
yeah. Actually, I'm not speaking. Just a minute. Just a minute. So a study is conducted at a factory which is manufacturing two type of chemicals, chemical 1 and chemical 2. Okay, in the following result. Okay, if a worker exposed to either C1 or C2, exposed means if he touches or he is any by default he got in a touch in any one of the chemical. Okay, but not both at the simultaneously. Okay, that means any one of the chemical he just touches or he got by default he just got touched, then the worker is at the low risk of developing a skin disorder. Means if the suppose the simultaneously if he got in touch with the both chemical, then it's a possibility that he may got uh, skin disorder in a high risk. But if any one of them is getting a touch, okay, then he will be a low risk of developing a skin disorder. However, if the worker is exposed to both C1 and C2, yeah, so as he is saying, he is at the high risk of contracting the skin disorder. If out of 370 worker in a factory, 320 are exposed to chemical C1 and 90 are exposed to C2, then how many workers are at the risk of developing the skin disorder? So that means this question is on week 1, and this is on the that this relation that not rotation set theory, right? You all know the Venn diagram.
I'm not getting that which topic is from.
Yeah, this is on Venn diagram. Suppose this is the number of worker which is got in touch with the chemical 1, and this is the number of worker which got in touch to, and this is the portion where the workers, this is the number of portion which got in touch with the both chemicals C1 and C2. This is like this you can form. So out of 370 workers, so we have given the total number of worker also, which is 370. In that 320 are exposed to 773. You can assume, right? You can here assume that, okay, suppose X is the number of worker who got touched with these two chemicals. So out of 737, so out of 92, I think, out of 70, 370, 320 exposed with the C1. So if it is 320, so what would be? This is 320 minus X, and what it will be this? And this is how many workers? 90 are exposed to chemical 2, which is, so this is going to be this one, right? Now we can calculate as you know. So asking for how many are the worker at the high risk of, means you want the value of activity.
X.
Yes. Triptiston, who's the next? Have doubt on this mock?
So,
The
can you
question
please
6
explain
also.
Mock 1 question number 12.
Okay.
11 and 12.
Okay. 11 and 12. Yeah, I will back to you. The sixth
The
is
question 6. Yes.
so 6 is also very similar. It is on the week 2. If a router is kept as position of 0 and its maximum transmission range is 10 meter. Okay, if Rohan is walking along a straight line L and his phone is in the transmission range of Wi-Fi of the router for a brief duration, then L could be, for all the options, unit is 1 meter. So suppose here is, you can make it like this, right? Router is kept here, okay, and so it is as the position of this position of 0 0, and maximum range is 10 meter it is given. So that means suppose this is 10 meter, this is 10 meter, so all side he will 10 meter he can reach. So this is 10 meter. Okay. Now Rohan is walking along a straight line L and his phone is in the transmission range of a Wi-Fi router for a brief duration. Then L could be. So what would be L here? So that it will be as so that means here you can see that the distances even this side also. Okay. The distance, if you check that, so even this side is also kind of 10 meter. Okay. So you can see that the transmission is a kind of circle. Okay. This is assumed these are all the 10 meter. Okay. These are 10 meter. So we want a line. So possibly, okay, like this, the line will go so that for a small time, right, it will be in a range, or even like this also, we don't know. You have to go with the option wise, that would be nice. And you have to check from the origin which give the distance 10 meter or less than 10 meter. Okay. Then it will give you the exact.
Okay.
Okay. Somebody have doubt on question 11 and 12. What's your doubt here?
So how are we getting the value of this constant 31.06?
For the 11th question.
Yes, sir.
So it is just substituting. No? You have some information. The information is here. One by one, you have h for male is, I think h is height, and f is the length of femur bone. Sorry, humerus bone. H is humerus bone. Separately, it is given. Okay, so femur bone is F, humerus is H, radial bone is R, and tibia. So, 14-inch human. No, this one is a question. This is not a question. Student calculators have calculate the living height of a person using this one. So HF, small h, HR, and HT. He calculated h height on the basis of this whatever you have. So that means for a person using height. So yeah, so just you need to substitute. No, here is HF is equal to, for one separately, for male you have to calculate, and for female you have to calculate. So for H, for male, one by one in this formula you have to calculate HF, HH, HR.
So can you show for male?
So just need to substitute here like 0.3, like 0, the H is H, the capital H, this one is equal to 0.3 HF. So HF is exactly your 1.9 plus 32. 1.9 F plus 32. Similarly, now 0.2. So HR here, sorry, HH. So HH is this one, 2.9 plus 27, H plus 27. And similarly for rest 2, you just need to calculate and multiply, right? One by one you will, for single, just need to calculate here. This is just a calculation mistake, I think you did. So nothing else. For similarly, for female, you have to calculate H. Okay. Only need to substitute in that, and this is just a substitution. Okay. Is it clear?
Yes, sir.
And this is for 12th question. Once you calculate that slope is for each one, if you see that, I think it will be equal or different. It is after calculating you will get. Okay.
So
Or
it's
even
different.
it is for for a female. It is a female. It is given length of bones. Okay. And for each female, you can go with the here. Yeah, it will be this intercept. So this side give you the y-intercept, and this is also the slope. So which having the more slope, that would be more steep, right? Here is like you can see 2.9 is the maximum will be like this. 3 point R which have 32. So it is totally different also. So it will be above of all. R will be right. Here is R. Just need to compare. R is going to be above to all others. So as you can see, 32 is here. 30 it's showing 32 and above. After calculating HR, like looking like maybe like HR is going to be above all. Similarly, this will not be. This will not be. In these two, you have need to go with that. So for others, you need to, for HT will be or HF. So similarly, HF is 2.7 and HT is 3.3, and sorry, this is HT is 2.3, 29 and 28. Y-intercept tells you that HT is the above. So which one is HT? So after HR, HT will come in this on this line, because 32 after 32 29 will come. So here is HT is 30 and 29. Okay, so here is again the same thing happen. Now still go with the H which one have the maximum steep, right? That slopes will give you the elevation. So this is 23 and only one have. Okay. So second option, if you see the third option, 2.3, because it have the separate 2.3. So this have two have the same and two have the different. So this is going to be your option after looking. Is it
Okay,
clear?
sir.
Okay. Anyone else have doubt, or we can start? Anyone else?
So question number 8, please.
This question, this of mock.
Yes, sir, mock test.
So don't worry. Solution will be uploaded, and also the TS will discuss even the solution if you all ask there. In this question, you have a function from natural number to natural number. The value is given f0, f1. So all is S1 is a set of natural number which fn give the even number, and S2 is the set of natural number which is give the function value is the multiple of 3, and the all n should be less than. So one by one you just need to calculate. No, f0 is given f1. Similarly, you have to find f2, f3, f4 till fn. You have to calculate each fn. You have to calculate, and in that you need to choose which one is give the even. That n just choose and fill in the set one. Similarly, which fn is multiple of 3, just fill in that natural number be given in this set, and you have to subtract or so that set operation is given.
Yes, okay.
Okay, let's do on week 4. So last time I took the session and we did division. Till division we discussed. Okay, this is done. I took a function and did a division of that I took two functions and I did the division in front of you. We discussed the division. So let's discuss ahead thing. So multiplication, addition also we did, and what is polynomial? We spent the time and discussed that. Okay. Degree of polynomial we have discussed. What is the degree of polynomial? How you will add and subtract two polynomials, how we'll do multiplication, and even the division to discuss. So division algorithm is in this section we did. So algorithm is you can. So let me open it once. So divisor, dividend, quotient, and remainder. So see, so as sir is also performing here, we took a very different function which is coming as a fraction. Fraction number is coming as a quotient. So so simply we can do a small, like if we have a 2x, suppose the divisor is 2. So in this form once you are doing, so this is called whatever you here. Suppose that means suppose you have a polynomial px and qx, okay, and px is let's say x square, or even let's say x cube plus 3x plus 1, and you have a qx is let's say I'm saying 2x plus 1. Okay, so whatever and you want to find the quotient, and even you can say remainder. So we'll tell you what is remainder. So once you divide px by qx, okay, so that means here x square plus 3x plus 1 upon 2x plus 1, or even let's say this is x plus 1 and this is x plus 2 here. So what you will get here? The question is what you will get after division. So directly, even if you see that this is if this is one is okay. So suppose this is x plus 2, this is x plus 1. So one thing you can do, like here is this could be written as x plus 1, and if you do the fraction as you already know the quadratic, and this is x plus 2 will come, and here is x plus 1. So this is you can cancel out, and this you will get here x plus 2. So by this one, or by doing the fraction, you can get. So you can see that this is a factor of this polynomial, which is a quadratic. So either you can go with this one. So this is this portion you can say this is called divisor, and this whatever you are dividing it here, which is x square plus 3x plus 2. So this is called dividend. Okay. This is dividend, and whatever here you will get, that is you can say quotient. Okay. And after dividing in last, if suppose 0 is coming, so quotient is 0, or even if it is any term is coming, so that is a remainder. Okay. That is a remainder. So let's do this division, how will perform here. So once we take divisor here, so one thing we need to take, okay, let's after doing this we'll discuss that. So we have the highest degree polynomial is this one, and take the highest highest degree term here in this, the quotient divisor is this one, and in this term, in this polynomial, the highest degree term is this one. Take these two and divide with that, so you will get here, that means x square by x you will do, that is x you will get. So just take here in the quotient x and multiply. Okay. So you will multiply in this whole polynomial, so you will get here x square and plus x. Now subtract here. So subtraction will happen here, so this will be cancelled out, and you will get here 2x. Okay. And now now this one will be as it is, will be down here. We'll keep here as it is. Okay, plus 2. Now take the again highest degree term, which is here this term, and this term in this polynomial is this term. Divide with that 2x upon x, which you will get here 2. Now right here, now multiply with the whole polynomial this px by 2 here, you will get 2x plus 2. Now subtract. To subtract, you will get 0. So remainder you are getting as we got here the same thing, right? Here is x plus 2, and also we are getting as a quotient. So this is quotient. Okay, so remainder, if you see that we are getting 0. Suppose I am doing, if you suppose this is 3 here, as previously we did. So this is 3 here, and you will get here 1, not 0. This will cancel out, and this will get 1. So remainder 1 you are getting, that means you can px upon qx, you can write like this even, which is you have x square plus 2x plus 3 upon x plus 1. So after division, you will get x plus 2 plus 1 upon x plus 1. So as this one is come as a quotient, okay, and this in division format in the numerator, it will come remainder here. And if you see that now you cannot you are not able to perform the ahead division. The reason is the degree here. This is one polynomial, you can say the constant polynomial. Okay. So degree of this polynomial is lesser than the degree of the divisor now. The degree of divisor is 1. But here, what is the degree of this polynomial? Anyone? What is the degree of this polynomial?
0.
Yes. So degree of this polynomial is 0. So 0 is less than 1, right? So now you cannot do the, you are not able to perform the division, this division, because the degree of remainder, the degree of whatever after subtracting you are getting, that is lesser than the degree of the divisor. So one thing is you need to note that. So this you can write like this. So this is the division you are doing here. So that means you can write px is equal to whatever the quotient you are getting, that means x plus 2 and qx. And at the end, the remainder is 1 here. So you can say dividend, okay, equal to quotient plus, quotient into divisor, okay, and plus remainder. Okay, this you can just say this is the division algorithm you have, and this whatever you will get in here in the remainder, okay, this will be a polynomial. This is a polynomial, okay, this is a polynomial, and degree of this polynomial is going to be strictly not even the less than or equal to, it is the strictly less than the divisor, degree of divisor. Okay, degree of divisor. This is one information we have this. Okay, not even the equal to sign will happen. Okay, not even this one. If it is this one, then once you can divide, you can perform the one more step of division. But it should be once it is the less than, strictly less than 1, there, then in that case you will not you're not able to perform the division here, and that is you can call as the remaining thing is remainder, and divisor is as it is. Quotient can be any degree. Even the degree of quotient can be more than that. Okay, it is not. We don't have any information regarding this. But one thing we note that remainder, degree of remainder is strictly less than degree of divisor, and this is you can say. So one thing is also we can note here. Okay, so degree of this dividend, okay, equal to, see, the degree of divisor is always less than the degree of the divisor. So that means degree of dividend is the degree of the quotient plus degree of divisor. Because once you add, the degree will not affect with once you add this remainder in this polynomial, right? It will be less than that. So degree will not change here. Degree is affecting because of this quotient and divisor. So degree, and you know the multiplication, once you, so this is a multiplication, right? So degree of the, if you are multiplying two polynomials, so degree will be the, after getting the multiplication, the degree of that polynomial, whatever you are getting after multiplication, is equal to the separate degree of that polynomials whom you are multiplying. Okay, means the quotient you are multiplying and divisor. So degree of this dividend is equal to degree of quotient and degree of divisor. So this is you can note also. This is one note. Only this much information we have. For example, we can see it here as the degree of px is 2, right? This is a quadratic. So degree of px is 2. Now degree of this is the quotient you got. So degree of quotient is 1, and degree of divisor is, we can say degree qx is actually x plus 1, so which is also 1, and degree of remainder we got here 0. So which is less than 1, right? So if you see that this 2 is exactly equal to these two, if you add after adding. So this is going to be true and this one is true. Based on this, we have some questions. This is just a simple observation. There is nothing more. Okay. Somebody said this. His name is A326. What's your doubt?
Sir, in activity 1, there is a statement.
Mhm.
Let me read that.
Of week 4.
Yes, sir. Week 4, activity 1. That a polynomial is an algebraic expression in which the only arithmetic is addition, subtraction, multiplication, and non-negative integer exponent of the variables.
Yes.
So, sir, division is not an arithmetic operation?
Division is no. Can you read out the word again?
A polynomial is an algebraic expression in which the only arithmetic is addition, subtraction, multiplication, and the non-negative integer exponent of the variables.
Okay. So here is see, it is asking for one polynomial, only single polynomial. Okay. But division needed, we are doing in between two polynomial, no? So that's the here thing is, if you are saying the
Multiplication also we need to
sorry.
multiplication for multiplication.
So multiplication is even in the single polynomial you can think it. Like you can write px is equal to, like here we got in the above thing, suppose px is equal to the same x square plus 3x plus 2, which is x plus 1 and x plus 2. In the single polynomial we are doing multiplication, but for division we are getting a separate. That's the definition actually. For if you think that this just a definition of the polynomial in the single polynomial, or polynomial is an algebraic expression in that, in which even the in the subtraction addition is also the same thing. Okay. The operations you can do is as a addition. For addition of two polynomials also we need it. So subtraction, and the reason is division is, you can think this is a separate thing. The reason is, as this is after dividing, you are not getting, this is not a polynomial.
Okay, sir.
After division you are not getting a polynomial, but in the rest three operations you will always get a polynomial. But after dividing this, or even doing the division between two polynomials, you will not probably get a polynomial. That's the reason you can think that it's better to restrict that. You can do the operations freely. Here is, you are getting a different. That's why the term is different, quotient, remainder. The separate we are dealing, but the freely operation can be performed. So that, see, after doing this division, you are getting different. This is a fractional polynomial, but not even polynomial. This is a fraction in the fraction, like in the rational form. But in the polynomial, we are doing the multiplication, subtraction, or addition. Still, you will get in the state of polynomials. After performing this operation, whatever you will get, that is also a polynomial. Okay.
Okay, sir. Thank you.
Yeah. So this is one thing, and the next is talking about graphs of polynomial. Okay. Identification and factorization. So let me see out how what are the properties we can see, or we can just see in the, okay, here is, we already discussed this one, that how the reason is, even I started the definition of polynomial is also with the different thing, like it is not saying to be a just algebraic expression. I discussed with the graph thing and said that the polynomial is the kind of a function in the graphically, you will see that it is a smooth. You will not see a jump or steps, or jump or steps, you can say the same, or a sharp corner. Yeah, it will be smooth. So as here is discussing, the same thing in this lecture. Okay, it will not, there will be no break, there will be not sharp corner, and it is a smooth. Smoothness is a kind of even the same. The word is smoothness means you can say that the sharp corner here or even the break. There will be smoothly you can see. This is one. This is one thing. Even if you see this, if you study the week 5, this is you'll see a graph of exponent is kind of this one. Okay, so this is also a, see, this graph is a very smooth, but this is not representing a polynomial. This is a exponential graph of the exponential. So here even you cannot directly say that, suppose I just erase that, then you cannot say this is a polynomial. Okay, you cannot directly say, while looking up the graph, you cannot even say, if you see that the sine function, okay, if you see the graph of the sine function, trigonometric function, okay, I will see that the graph of sine is, somebody knows that, then it is like this. Even in that you will not see a sharp corner, but that is not again the sign. While looking, you cannot say it is look like this is represent a polynomial. Even you can form the similar thing, but if you exact draw the graph of sin x, that sin x is not a polynomial. So means to say, even if you have a graph and somebody says that, or even saying to be the compare which one may represent, not exactly the polynomial, may represent. So this is a possibility, this can be a polynomial, but once we know that this represents the sin x, so sin x function, so this is not a polynomial. But if it is if the question is like which one represent the polynomial in this, some graph is given, so in that, using the sharp corner or a break, you can neglect this option, saying to be that is not a polynomial, and this may represent, and this some other, suppose this is exponential, so this may also represent, not exactly, but we know that these are the exponentials, so we can directly say this is not represent a polynomial. But suppose the exact function we don't know, then you can say, yeah, this could represent a polynomial. So means to say polynomial is, if you see the graph, that was a smooth thing, and you will not see the break and sharp corner.
So
Now, yes.
sir, why does the sin x not is a polynomial? Because it is in a round corner, not in a cross. Then why it is not?
So even see, only the because of the sharp corner, or because of the jump, sign don't have this one, so you cannot call as a directly polynomial. A polynomial is expression as the definition. So better, so graph, you can say the graph of polynomial is smooth, okay, but
Yes.
polynomial, as you go with the definition, no, just now see, read out the definition. Polynomial is an algebraic expression in which you will perform addition, subtraction, multiplication, this operation you can perform. And also I said the expression should be like this, not even the different. Okay, in this, the expression if in this format is given. So such kind of expression is exactly, you can say, so better definition you can say, in this type of expression you can say a polynomial.
Okay,
So
sir.
sin
Understood.
is 6 different, no? Sin x is different, totally different expression.
Yeah, sir.
So this
Thank
is
you,
the
sir.
definition for polynomial. And the next thing is we just briefly gone through the roots. So root of a polynomial is, the definition of root is just saying to be where the function have 0 value, the output. See this, if you draw the graph, okay, suppose this is y-axis, this is x-axis. So x-axis you can say the input set and y-axis is the output set, and using that you are make a points, right? You can make a points and draw the graph. Here is x value you will give, and output you will get x value, input output, input output you will get, and you can make a, while joining these points you can make a graph. So the points where the function value is 0, that is called the root of the polynomial. You can, for simplicity, you can see that we have x square plus 3x plus 2. So this polynomial have two roots. One thing also, last time I discussed that if you have a polynomial, okay, which have degree is n, okay, which have degree n, that means it have at most n number of different root. A root, and just now I'm saying root means you have function output is at that point is 0. So this is one thing to be noted, that the degree, and there is a relation between the degree and the number of roots. So for this polynomial, if you draw the graph, you will get here, so you can do the, this is x plus 2 and x plus 1. So that means this side the graph will be this one. This is -1, this is -2. Okay. So this is the roots where the quadratic give the quadratic value at this point at -2 and -1 is 0. The same thing. So quadratic is nothing but, if you see the category, this is also a polynomial. Quadratic is also a polynomial, but we are specifically reading or have a week 3 because it has some different uh, uh, property, like you can say the maximum, minimum, upward, downward, to these two things, and also slope we studied directly using the formula. In the polynomial also we have slope, but we'll study in the calculus portion, because the slope is of a function is the broader definition. We'll see in the calculus portion. So that's the meaning here, roots. Okay, and if the polynomial have degree n, then it have number of n, means at most number of it have the root, which is at most it could have the root is n, means it could be lesser than that, different roots. The multiplicity also you can think. Okay, so we still remain to talk about the multiplicity. We'll discuss that. So that's the meaning here, root. Okay. Now after doing the roots, suppose you have a polynomial. Suppose px is equal to x square plus 2x or 4x plus 4. Okay. Suppose you have a polynomial. So this is also a quadratic. But we can think this is a polynomial. Quadratic is nothing but also a polynomial, and it is also matching with the definition of polynomial. But it is a quadratic. So if you do the, as we know with the doing the factor, so this will get, you can write like this. Okay. So here the root of this polynomial is minus 2. Okay, one root is there which is minus 2. Okay, but it have, see that it has some multiplicity. That means the minus 2 is the root, but it have two multiples. And here is multiplicity means here, see, minus 2 is a root, but see that what is here, even you can say this degree, the terms you are getting. If minus 2 is the root, now you can see here. So the multiplicity of this root minus 2 is 2. That's the meaning here, multiplicity. How many number of times it is going to be? So minus 2 is the 2 time root of, you can say, the of this polynomial. Or in different word, if suppose alpha, suppose you have a polynomial, okay, x, and you did some fraction here and you got x minus alpha as a root, sorry, alpha as a root. So you can write like this. So one thing here I didn't tell you, that if alpha is a root, no, for a polynomial px, so that means x minus alpha is going to be one factor of that. And different word, if you divide px by x minus alpha with this polynomial, you will get a simple quotient. You will get remainder as a 0. You will get a remainder. Once you divide with that, you will get remainder as a 0, and you will get a simple quotient. Okay. So this is one thing to be noted, that if it is a root is given, suppose our number is a root of a polynomial, that means x minus that root is going to be a factor. Or even if you divide, or in different word, if you divide that, the remainder you will get as a 0. That's the meaning here. So that means if px is polynomial and alpha is a root, and suppose while doing the factor, getting the factor, suppose you got like this, and support the different polynomial qx. Okay, there's the multiplication. Or even let's say this is m. Okay, in that case, the multiplicity of m is going to be, sorry, multiplicity of alpha is actually m. That's the meaning here. The multiplicity means, for if a root is given, the root of a multiplicity is, here is the meaning as how many times that px becomes 0 because of alpha. So here is, you can see, because of this is called, this number is called multiplicity of a root. Okay, so because of this multiplicity, we have some property. Okay, and also actually it is a play a crucial role. It have some crucial multiplicity, and just a minute. Because of this number, the polynomial play important role, that here, suppose, okay, one thing here, suppose this m is even. Okay, suppose this m is even, and once you draw the graph of this polynomial, in that case, suppose here is the m. So at m, the function value will be 0. So in that case, if m is even, so the polynomial behaves like this. It will touch the point and will back. So see that it is a play a crucial role in the defining, you can say, or giving a structure in a graph, means here in the graph of the polynomial. So if it is even, then it will touch only and back to the same direction. Okay, if it is a positive side, if it is a coming, okay, we will see that. So suppose the polynomial is like this. Okay, px, which is x minus alpha is m, suppose another root beta. Okay, so you can write like x minus beta, and suppose the multiplicity of beta is, let's say, m, and another is, again, another is, suppose you have another root which is delta. So x minus delta, which have multiplicity is 1. Okay, so multiplicity is 1 means simply you can write here 1, or you can say without that you can write. and the rest is clear. Okay. And suppose this number m is even and this number is odd and this is one we have already. So, okay. So this is we have now as m I am saying it will be back to in the same side. If it is in positive side, so it will come here, okay, and back to the same side. In the same positive or negative side, okay. Only in the not quadrant here play role, only that side. That means it is a positive side of the y-axis or in the negative side of the y-axis. In that the same direction it will reflect. And another thing is, suppose for the even case it will happen. Suppose here is n, okay, n which is odd. In that case, how it will perform? It will look like this, okay. It will pass here. It will be like this. Okay. It will cross with the not exactly linear form. It is kind of like this. It will cross. Okay. And delta is another root which is have multiplicity 1. So here that means at that side it will be it will exactly the linear. It will be like a line. It will cross that delta here. That is delta is a root, right? So at that point, well, function value is 0. That means here this is also differently you can say that is called x intercept. So as you know the x and y intercept, right, all of you. So this is intersecting the actually one thing you can say to the x-axis. So where it is intersecting the root, that x intercept is nothing but the root also it is called. So here is at delta is the multiplicity 1. So it is a look like a line. It will cross that x-axis like a line, exactly line. So 3 cases. So a number could be even or odd, right? Or you can say exactly 1, or even you can say 1. 1 which is also kind of odd, but while they're defining the structure, it play a important role as at that point it is passed through like a line. Okay. And when it is odd, it will be passed like this. And if it is even, then it will touch that point and back to in the same area. So these 3 property, because of this multiplicity only, while defining the it's defining the structure like this. Okay. So can you tell me here, if suppose this is A, this is B, this is C, and this is D. Okay. So what is the multiplicity of A, B, C, and D? Can you tell me anybody? Anyone?
1.
1. The reason is it is look like at the intercept or even the roots at the roots point here, it is look like a exactly line. The very in a small range, you can say in the small in a small range, you can say it look like a line, a straight line in a small range, you can say. That's the meaning here. That's the use of multiplicity. Okay, so just a minute. So even you can say the root of polynomial or zeros of polynomial or x-intercept, different name is given there. So if you say that in this video, sir is talking about just only the root. So what do you mean by the root? So that's the here we just now discuss here. What is the meaning of the root? So root is, if it is a root, then it is making a factor. So we'll see it how we'll do the factor, how we'll get the root. Okay, different method we'll see. So and then after we gone through just now the multiplicity. So what do you mean by the multiplicity? So what does mean by the multiplicity here. So the roots depend on the roots. And next is the behavior at the multiplicity or in the x-intercept. So different word why it is called x-intercept, as it is a dividing. So if you see that this is the here is, you can say, it have multiplicity even, and it have multiplicity is odd, and here it look like a linear, so it have multiplicity 1. Okay, so this is the mean here. Okay, and now the next thing is the graph into behavior. Now we meant to talk about the into behavior. So why we are studying? See, the reason is why we are knowing this. So after knowing this all property, we will discuss, even we can say we will trying to using these all property, we will try to graph the polynomial. So if somebody give the polynomial, we can directly say that how the graph will look like. So still remain to know the property of ind. How the ind means ind. What does mean by this ind behavior? So ind behavior is, see, we are dealing with here only some suppose let me make a different. Suppose here is polynomial, okay, and suppose this is look like this, okay. So this is touches and back to similar, and this is a linear, so it will be a smooth. So this is a smooth. This is the touching point. So this is suppose a polynomial, okay. Now ind behavior means how the polynomial look like when x goes to infinity. See, this is some particular point, suppose 5, 10, 11, 100, 1000. But how the graph, once x is going to be bigger and bigger, here is x tends to infinity means x value is going to be bigger and bigger. That's the meaning here, x tends to infinity. And infinity is saying to be positive, infinity is saying to be positive value, means positive bigger number, and negative infinity means negative or very less number, very small number, or negative bigger number, you can say in different words. So how the behavior it will look like? It will go this side or it will go this side. By using, like, by looking the polynomial of the coefficient, we can tell by looking the coefficient only. So we'll see it. But that's the meaning here. Like, what do we mean by the end behavior is this. See how the polynomial, as it is ending side at is a bigger and bigger number, how it will be. It will be go positive side, means it will be give a positive bigger number or negative bigger number. As you give as an input as a positive number or negative number, a large number. So for that, only the one coefficient will decide this. So suppose you have a polynomial px, okay, and which have degree. Here is coefficient and degree will decide this, how the end behavior will be. So suppose we have polynomial, let's say an x to the power n plus an minus 1 x to the power minus 1. Okay, and this is the graph of the polynomial. Sorry, we have this polynomial. So degree of this polynomial is n. Okay, this we have n, and so this is the degree here, and these are called the coefficients, right? These are the coefficients. These are all the coefficients. So take the highest degree term, this one, okay. The end behaviors actually tells you that take the highest degree term in the polynomial. So we have, this is the highest degree term which have degree n, okay, and take the coefficient. So it has some property right now using this one. So for that we can make a table. How the based on this one, how the in behavior will look like. Suppose the cases is here. Okay. Suppose this table is the case for a is greater than 0 and this case is for a is less than 0. Or differently, let's say the case is n is in this portion which is odd, okay, and this is for even. So suppose n is odd here, okay, in this portion n is odd, and here is n is even. So suppose the case is n is odd and the coefficient, now see, we fixed one, n is odd. Now fix to the coefficient of highest degree, which is we have n, of the coefficient of degree that n have. So take that. Now suppose this n is, that coefficient an is positive. Okay. If an is positive, what is going to be in that case when we give the input as a positive real number? That means you are going this side positive. So what is going to be the polynomial in that case? How the polynomial output you will get? You will get a positive number, means bigger positive number, that means positive side of the y-axis or negative side of the y-axis. What you will get here? Am I audible?
Yes, sir.
Okay. Okay. So okay, I am discussing. So in this case, if x is positive, means you are going to be a very large positive number, like this side is. Okay, let me make it here. This side is. So the output you will get here, because of this reason as is a positive, you can say this is going to be positive. If x is going to be minus negative side, so here is different case will arise. So if the negative side it is going, that means this side, this is the larger negative side. So in this case, the polynomial go below side. Okay. Very large negative number you will get here. So in that case, you can say x is tending, you can say, or you will get output as, because this infinity means you are not exactly getting the number, but you can say a very large number. So output also exactly number you will not get, but you can say that it is going to be larger positive number or larger negative number. Okay, that means very small number. So in this case, it is going to be also very small number. That means very large number which will be negative. Then
So,
an is positive. Yes.
so can you explain with that graph?
So here is actually I'm saying, no, in this case here is
Okay,
that's
okay.
right to say. So if it is a very large number here, so let me, if it is a positive large number, so this side it will go. If it is a negative large number as here, so this side will come here and it will be going to be negative side.
So can you please take on an example?
So for example, okay, let's do an example on it. So let's say px is a polynomial. Okay, well, let's say this is 5x to the power 5 plus 2x plus 1. Okay, and another polynomial is px is equal to 9x to the power 3 plus 2x plus 1. Okay, this two we have. So see that in each case we have odd degree, and this is one positive and this is one negative. So highest term coefficient you will take. So this is the degree and this is your coefficient. Now let's draw the graph of this polynomial. Okay, how will look like it? So I have Desmos open. Let me open the Desmos here. So we have first one is minus 5 x to the power 5, okay, plus 2x plus 1. So if you see this, so in this case, this is odd degree polynomial and this is negative. So once you are substituting here positive number, this is the x-axis, this is y-axis. So once you are substituting, see this very large and large number. Oh, so the cases is for, I told you, no, I was correct, but this is it. So this is minus, okay. Oh, sorry, I'm making a mistake here. Sorry, this is x. Both cases, so okay. Here is only the positive we discussed. No, okay. So I made here negative also. So let's say this is the case here. Let's say this one is the polynomial we have. Till now we didn't discuss this one. Okay. So positive and odd degree. So see that this is odd degree and positive we discussed. Okay. So in that case, see that this is going to be larger and larger. If you see this, it is going to be that side is very large number output as you are getting very large number. You substitute here very large number, you will get output as a very large number. Differently, you can see here you are giving the very large number, you will get positive large number. If you are giving, okay, so here is case here. So here is minus infinity. You are correct here. And you are giving as input very large negative numbers, so you get output very large negative number as here. This side is negative, no? So if you substitute here, you'll get very large number. We don't know even very large number you'll get as well. That side is the graph is, you see this is look like exactly to the y-axis. Will match with the, if you go with the head thing. Okay. So this is the differences here. Yeah.
So how do we actually draw this actually? I mean, with the end behavior.
So that's why we are unable to discuss. We are actually, we are not exactly the number we have, but that's the meaning here, how the graph will be. So that's the meaning here. It will be in lie in the positive side or negative side. So better to say this side. If you are going to very large number, in which side it will be below side or above side. So that's the here thing that if you say if it is a positive side, you are giving very large number, you will lie in the positive side. So see that if you are positive side, this side you are giving it as a very large number, you will lie in the positive side.
So
Output side, positive side. You are giving the very large negative number, you will lie in the negative side. That's the meaning here. That's the I wrote.
so but the graph is coming from the negative and going to positive, no?
That's the one thing.
So but here you have written positive to positive.
Positive to positive. Here is going means what? Here is, so if you are, because of this you are getting, so let me make like this. Is it clear now? The arrow
Yes.
is, now I hope is it clear. So here we are actually, so see, either you can, yeah, it is my fault, otherwise you can say, yeah, this side you are, say like this. Or if you suppose I just bound this side, so graph will be, suppose you are drawing the graph from positive side to negative side then. So it doesn't tell you that because of this direction is there is no mean, but only we needed how the graph will look like. The thing is how the graph will look like. It will lie in the positive side, negative side. It will behave like this one, or it will behave like just reflecting linear. Okay, it doesn't matter. Here is mean to say how the end behavior, if you are going to, or even if you are very large negative, end behavior means you are giving a very large negative number, what will be the output? It will be a large negative number or it will be large positive number. That's the meaning. This is one thing. Now, if you suppose an is negative, what is going to be in that case? If an is negative, so if you suppose you are giving a very large positive number, still you will get a very large negative number. minus. And if you are giving a very large negative number, you will get. So the reason is you can say minus this one and this minus makes a positive output. So directly better to like remembering it is like this negative number and this negative number give a positive. For positive, this positive and this negative gives as outputs negative. So this is going to be large positive if the case is negative. And we have already noted it here. This you can say. So in Desmos, even if you just write here, if I will write here minus, we'll see this here. If you are giving the large negative, it will give the large positive. If you are giving the large positive, it will give the large negative as here. So even to remember this one, you can think like this. Thinking to be just say this is negative and this is negative input you are giving, so it will become a positive, or positive and negative will become negative. Now think about when the n is even and an is positive. In that case, what will happen? You will give large positive, you will get large output also. Okay. If you substitute, if you are giving a large negative, so this negative, if you give input, so here is degree also will play a role. So negative, you are giving negative, because of negative we have even degree, so it's make a positive, and this positive, and after getting the input negative, that what I mean to say. Suppose you have polynomial px, let's say this is 5x to the power let's say 4 plus 2x plus 1. So if you give here minus 2, okay, as the input, so this will become positive, right? This will give 5 into 4, which is 20. So why here this highest degree term play a crucial role is reason is also, if you match with the other terms, it gives the maximum output, and you need to add this. That's why it is happening. It is not, you don't need to remember it. You just need to note here, because of this highest degree here, you will get substitute input. It gives them very large number in compared to others. And after coefficient also will decide the sign. And if you add those all, you will finally get, because of this large number, it will give as a output. It's actually depending on, it's totally depend on, because of that region, because of this region is going to be very large number. So this become positive, and because of this even, so if you substitute here negative, because of degree even, it will become positive, and that's why the positive, and multiplying with the positive number, it will give the positive. And when an is negative, then again the cases is here, you can think we are giving as, so now you can think this is a positive input you are giving, and degree is even, so again it will be still positive. Positive and negative, it makes you know that negative. And when x you guys gave an input negative, so negative input and even degree, it makes you positive, and positive and negative, it again will give you the negative. It will become positive input. See, this is negative, you gave input, it become positive. So positive and multiplying with this coefficient negative, it again will give you nothing. So I think these are the rules we have, and you can also.
Will that go downwards? Like when even degree and a is less than 0, will the graph go downwards?
Yes. So you can think here we have, okay, suppose polynomial you have px is equal to minus 5x to the power 4 plus 3x to the 3 plus 2x plus 1. Let's see that how it will be. So let's say that we have the graph is here. Okay. So let's say minus 5 is there, okay, negative, x to the power 4 even is there, and 3x cube plus 2x plus 1. So see that still you are giving the negative large number, you are getting, sorry, still you are getting the positive large number, you are getting as what negative, as here. Very large number is this side, okay, this side, and output is this one. And very large number is still you are getting positive, but it give the output negative, very large negative, as here. Because of this negative we have term, negative even degree we have, but it's still very large positive you are getting, but it's still, but here you are getting very large positive number, but still you are getting very large negative, as here it is happening.
Hello, sir.
Yes.
Sir, I have a doubt that how the graph starts. I mean, from upward or downward.
How the graph start?
Yes, sir.
Start means what?
No, sir. He is asking how the actually we can draw the graph. Like
I mean,
for
sir,
that we need to
from
find
where
the
we have to
roots and
take
all.
from upward graph or
See, what do we mean by there is, if you are deciding the direction, there is no mean of direction. What do you mean by the graph of a graph? What do you mean by the graph? You have a polynomial, okay? The graph means what? You are in the coordinate system, that's why you are able to say that this is line is passes through like this, But what it mean that? What do you
yes.
mean by the graph exactly? The graph means you are giving the input and you are getting the output. You are giving some value, you are getting output. Giving input, getting output. Giving input, getting output. Giving input, getting output. So using that, you will form a point. You will form a point. That's all. And these points can be noted here. So there is no direction, I mean to say. Here is whatever that you are giving input, you are getting output. So if you draw, it will be like this. That's all. That's the meaning here, graph. So here is not direction is this one or that. You are giving input, you are getting output. Here is one kind of direction is representing that at the end side. Means you are going to be positive. So what here it tells you that suppose this side now after it removed like this, and what it will be. So here I just given the sign. Reason is as you are giving the very large, output is the graph will be you are getting very large number. We are unable to draw the graph, but this sign tells you more. That's the meaning here, direction. Otherwise, there is no mean of the in the graph. There is no mean of the direction. Okay. So using all this, so this is the use of so there is no mean of the graph. So here is the reason we don't know the exactly what is going. We are giving input, but we are getting output. So in the graph, we are giving the direction. Otherwise, there is no. So these are the end behavior. This is the mean of end behavior. Okay. And now we all set here to draw the graph. Now it is enough. The enough property we know, or anything I'm missing. Let me once check it. Now, yeah, this is one thing. Number of turning points still remain. Okay. Number of turning points. So see, these are all things, end behavior, multiplicity, this everything is actually will use in the drawing the graph. So still one property is remain, which is turning point. Turning point. So what does mean by the turning point? So let me fix once. So we still see that sir is talking about the in the behavior when the case is even, when the case is odd. Now the turning point. Once you study the calculus, no, everything, no need to remember, or everything will be clear with the once you know the turning point. Somebody has raised hand. Others.
Hello,
Yes,
sir.
others. Yes, others.
Sir, I have a question. We have given any polynomials. We have to find the fx is strictly increasing or decreasing in any value. What value?
Uh,
Where the
oh,
function is strictly increasing or decreasing. How can you find the answer this?
okay. Okay, okay. So after this turning point, we'll discuss that. Yeah, the roots actually decide this one. So no roots, not roots even. Yeah, turning point also will play a role. Okay, we'll see it how it is. So
Okay, sir.
turning points will help here. So what do you mean? What does mean by this turning point? So turning point is. Let me draw the graph here. Okay, here we'll discuss. So if you see this, we have some turning point is the turning point means this. If you see this we have. So these are in here. If you see very clearly, this one, if you see this at this point, what is happening here? It is if you go with this side, okay. If you go with this side, as generally we go means here the from negative to positive, we'll usually use the sign. Otherwise, there is no direction you can say. But let's see that we are giving input from negative and I'm going increasing and approaching to the positive. Here it means to be I'm giving input and getting output, giving input and getting output. So let's take, even you can say giving positive input and giving getting a output, giving input. So there is no mean of direction, but always generally there is a, you can say, a convention that let's give a very small number and get output. No, generally how we will start from ascending, sorry, descending to ascending, right? Some small number and then ascend. That's the we generally do. So similar, give the very small input and get the output. So that's why the negative and negative to positive we generally approach. Otherwise, there is no mean of direction. So suppose like this we have, okay. Suppose the graph is like this. So at this point, what is happening here? So from negative side, not negative, even you are like this here. These are the inputs, right? These are the inputs and you are getting output. What is happening? So because of this increasing and decreasing here, it's the word happens. As in the range, you can say, see, you are giving, okay, so still the word telling you the increasing and decreasing. So here suppose fx we have fx function fx. Okay, I think sir have taught about the increasing and decreasing also. A function is said to be increasing. Okay, suppose you have function fx is equal to x square plus 2x plus 1, or yeah, let's discuss. So you have this function. Okay, so if you substitute here fx is equal to 1, what you will get here? Sorry, here is 1. What you will get here? This is 1, this is 2 plus 1, this is going to be 4. If you substitute 0, what you will get here? This is 1. And if you substitute minus 1 also, this is going to be 1 minus 2 plus 1, this gives 0. And if you substitute here f minus 2, this is going to be 4 plus 1, this is 9. So what is happening here? If you see the graph here, this is going to be minus 1 is here. This will be like this. The graph of this function is this. So if you here, suppose this is minus 2. So what is here? You got output 9. Here is minus 2 and got output 9. And here is, yes.
Sir, if you substitute minus 2, then we will get 1 only.
No, if you substitute here minus 2. So this is 4.
Yes.
Okay, this is minus 4, sorry.
Yeah.
This is minus 4. This is minus 4 and this is 1. This is 1. Substitute minus 2, you'll get minus 1. Sorry, 1.
1.
So if you substitute minus 2, you got here 1. So what it means that you are, as you are giving the negative value, you are getting here outputs here. So that means your function at here minus 1 till here to negative, so this side till here, this is axis of symmetry, this is in a quadratic. So this side you are giving, see, the minus 2 is, or even let's say minus 4 is lesser than minus 2. Okay, and this is minus 1, this is 0, this is 1. So what is happening? This is the chronology, or even since this is the increase from negative, this minus you are getting. This is the inputs you are giving. The outputs are like, these are the input. If you suppose you are giving, the outputs are what you are getting here at minus 4. Fx is equal to minus 4. Suppose this is minus, then you will get 16 minus 8 plus 1, which is here. This is 8 and this is 9. So see that what is happening? This minus 4 is lesser than minus 2. Okay. So at minus 4, this is less than f of minus 2. No. What at minus 2 you are getting 1, at minus 4 you are getting. So see, this is happening. Outputs you are getting this side. This is minus 2, and this is a minus 1, you are getting 0. And this is f of minus 1. At 0 you will get here, and this side is now started increasing. So what is happening here? You are giving the inputs, okay, and you are getting the values. So see, this minus 2 is bigger than minus 4, but output, what you are getting output, the output is getting the bigger than in compare of this one. The minus 4 is lesser than minus 2, but output you are getting this one. So in this case, what is happening? It is decreasing. Okay, it is decreasing, and in this case, you are giving input number bigger and bigger. It is also increasing the value here. So the simply definition is a function, okay, said to be increasing, okay, increasing when f of, let's say, x1 is greater than f of x2. No, the reason is if x1 is greater than x2, in that case, the output is also in the same direction. We are getting the same. The numbers is increasing. See here is sign is changed. See clearly. But here if you see, if you are writing here, then will get the same. This is the mean of increasing. And decreasing means you will see the inverted sign. Inverted sign, a function fx is said to be decreasing. Okay, if x1 is still the case is x1 and x2, inputs they are increasing, but output is the reverted one. The same as here the cases have. Okay, this is the mean of decreasing and increasing. So here is happening, here is a, you are giving the very small number, but the outputs you are getting larger. This is the mean here, decreasing to till 0 it is decreases, and now it started increasing. Now the same is here, the turning point. Now the turning point is, what is happening here? You are giving the input. So you are getting output as a, this is a decreasing, no? Output is also a smaller number. Being giving as you are increasing side, here output you are getting smaller and smaller. At once here, at the here, after this point it started increasing. Your number is also increasing and also output is also started increasing. Till here it is here. And then after again the decreasing is here happening. Your number is increasing, but your output is decreasing. Simple. So where this point is happening, this point is actually called turning points. A number, the value of the output values are changing from decreasing to increasing or increasing to decreasing. So this is the thing here. Here, these points are actually called the turning points. The function behavior is actually, as the value you can say compare, it is actually changed. This is the change here happening. These are called a turning point. So here is one thing need to be noted. See, I told you the case here, the multiplicity, where one case is there that if it is even, then it is back. It will touches and back. So this is one kind of turning point in the even case. But for the odd case, it is behaving like this, right? This is just process, and like this it is behaving. So see that it's look like a turning, but at this point is not turning point. Okay? This point is not turning point. Not turning point. So in odd cases, whatever the roots you are getting there, that is not a turning point. But at multiplicity, where have even, that is a gives a turning point. For linear case it is the not case, right? It is not changing from negative to positive, it is a continuous. But for even multiplicity, it is actually changing from negative to positive, or sorry, increasing to decreasing, or if it is like this, then increasing to decreasing here is happening. But for the odd case, it's look like a turning, but it's not a turning point. You can see, for example, we can see here x to the power 5 even, you can say. Okay. See that it's look like it is turning, but it is not exactly turning. Turning means here, that's why the analytical definition we needed. Turning means the function value is from changing from negative to positive, increasing to decreasing, or decreasing to increasing. At that point, it is function value is changing. But here is the case. At here, this is not the case. It is continuously increasing to increasing cases here. So you can directly see here, if you are analytically, if you think that suppose fx is equal to, here I wrote 5x. So suppose you substitute here fx in input, you just give -1, you will get -2. If you substitute 0, you will get 0. At 1, you get 1. So see that what is happening here at 0, the function output you substitute here -10, you will get output here. So similarly, if you see that if you give the smaller number, it will be look like this. So it is like this, and then continuously increasing and increasing case is there. There is no, it's look like there is a behavior, but there is no turning point. So this is not a turning point. This should be noted here. Once it is odd cases happen, it will not give the turning point. So turning point, that's why the better definition you can say the turning point is the function values are changing here from negative to positive or positive to negative. But here the cases for the odd degree, we will see such kind of thing is not a turn. So that's the meaning here. Now in some ranges we will see some question that where it is increasing, where it is decreasing. So suppose I am just writing polynomial px is equal to x to the power minus 5 cube x to the power minus 2. So this is 4 x minus 0. Let's say this is 2. Okay, x minus, sorry, this is in multiplying x minus 1. These are all in multiplication. X minus plus, sorry, x plus 1 here is going to be your, let's say, 4. Suppose this is a polynomial you have. If you do multiplication, you'll get, what is the degree of polynomial? This polynomial, what is degree of this polynomial?
4.
What is degree?
13, sir.
14.
14, right? This is 4, this is 7, 7 is 4, this is 3, 4, 7, 9, 10, and 4. 4 is 14. So if you draw this graph of this polynomial, how it will look like at 2. Now see that the turning point and the multiple still play a role here. See, at minus 2, or let's say from 0, or even let's say do from 0, 0. So let's say this, remove that, and that's exactly here is the axis. There. So at 0 it is even degree. So that means at 0 it will be touches and back. And also need to be note that first thing, okay. So okay, we'll see it how it will be. So first thing is need to be note that in the behavior. Okay. So what is going to be the degrees here of this polynomial is 14, and highest degree term coefficient, what it would be? It would be positive or negative? An, that an.
Positive.
It will be positive, right? Because if you see that multiplication is all are positive. If any one of them negative, then it will give, because of this one, you need to decide that what is going to be negative or positive. Okay. Suppose I just made it here negative. Okay. Suppose I made it, this is minus x minus 2 is there. So what is going to be in that case the coefficient?
Negative, sir.
No. Can you tell me why? Still the degree will play a role here. If you open it and then multiply, so it will give positive, right? Still the an is going to be positive. So that's why I just made, if it is here negative, okay, here it is negative, but yeah, this is positive, this positive, all are positive gives, and one is there is negative. So in that case, this is going to be negative because of degree is minus 3. Okay. So let's assume our case is as we previously assumed that. So this is positive. So that means in this case, in the behavior is how x is going to be positive, or let's say first even negative, x is going to be negative, then how px will go? This
Positive.
is 40 and this is positive, so this is positive. That means this side. That means what it tells you? Negative side, that means you are getting output positive. That means
Positive
your
is
polynomial
second quadrant. Yeah. Second quadrant.
like this will come. From this one, we don't know what is going to be in the window, but yeah, it is coming like this. Decide you how it will be upward or down. Okay, this one decided. Now this side is came and h5 at, so here we have minus first -1 is one root here. This give -1 root. Sorry, x is -1 as a root. Okay, this terms will give a -1 as a root. So which have multiplicity 4. That means I don't know how it will come, but it will be, suppose here is -1. Okay, it will be like this. How it will come? It is actually continuously decreasing, and it will like this and back. Okay, this will back. We'll see it here. Then after -1, 0 is there. Okay, 0 is there. 0 will come here, and 0 of the the 0 root is we have, and which have multiplicity again 2. Again it is even, so it will be go and again touches there and back at 0 also. Okay, and we have then after 1 is there. At 1, the degree, the multiplicity of 1 is a root. The multiplicity of 1 is 1. You see that this is 1. So that means here is suppose 1. So it will be
Again bounce back.
not bounce back here. It
No,
is
it will cross. It will cross.
It will cross linearly. So it looks like a linear. Now after -2, the 2 will come, which is again
There it will bounce, no?
so here is -2 here. So it will be come to here and bounce back here. Just touches and back. Because as here it is a even. Now 5 will come here. So it is will do here and
it will cross.
It will cross, but it will cross like this. Not linearly, it is reflecting, like not reflecting.
Oh.
That is word is proper word is there is some word.
Yes, curve.
Yes, kind of, yes. So let's say this is like this, it will go, not linear. And then again, so as negative side is positive, okay, as it is negative side is positive and positive side is still
Also
positive.
Positive
So
side
that
is also
means
positive.
our polynomial is go like this. So this side is positive and this side is positive.
Sir?
Yes.
So can we draw this graph from left to right?
Yeah, better to always draw from left to right, because that's why the in the behavior we needed, and see that's why in which side it will lie, it will be upward, like where these points will lie, like this turning points, where in this in below side or upper side. Because of this side in the behavior will tells you how you are coming, right?
Yeah.
How you are approaching, and then decide the line. Otherwise, even this one also, you can say this side or okay, you are decreasing and okay, like this, but you needed one side at least. So better always to be like, that's why thinking like this. It is, see, your inputs is actually you are used to think, right, from negative, from a small number to increase. So that's why your output is how it is. The output how you are getting. So better to think like this. So from negative, you can think, okay, we are approaching to this.
Okay.
Otherwise, there is no mean of direction.
So since an is greater than 0, that's why graph is coming from upward.
Yes, that's why we in the behavior needed. No, we decided first. It maybe if it is negative, then we have to go from negative side, no, from this side, and then again have to decide. But our graph is positive. That's why we decided. That's the use here. It is going to be upward or down. Okay, this is one thing, and I still we forgot the turning points. So number of turning points, there is a relation between the number of turning points and degree of the polynomial. So if suppose a polynomial px we have, okay, it have degree n, okay, degree n, then number of turning point is what would be? It would be number of turning point is less than or equal to n minus 1 or n. I think n, right? N minus 1. Less than or equal to n minus 1, I think so. As the definition, as you can see here in the, let me see once. Number of turning point is and less than or equal to n minus 1. There is not much use of number of turning point. Turning point is actually deal with the
n minus 1, sir. N minus 1.
N minus 1.
Yeah, see, there is it is written. We can
n minus 1.
n minus 1. So if degree is n, then utmost number of turning point, here's the utmost number of turning point would be less than or equal to n minus 1, or less than or strictly less than n minus 1. Okay, so not less than, you can say strictly or no. Now utmost number of turning point is n minus 1. Okay. So we can verify it actually for our function. So see, we have 14. Okay, degree of the polynomial is 14. So it may have how many turning points? It may have less than or equal to 14. Sorry, less than 13. So this is one turning point, 2, 3, 4, 5, 6. Only 6 turning points there. So let's graph first our graph is correct or not.
So can we not say that in -1 it is not it is a turning point?
I think I missed that. No, at -1, yeah, this is one. Yeah, this is one turning point.
Oh, okay.
Yes, this
So
is
the points which are not crossing over is a turning point.
Yes, you can say.
And in that 5, that is cannot be a turning point because that's a kind
It
of
is not
yes
a turning point. The reason is it is actually fluctuating. The word is fluctuating.
Okay.
As kind of as statistical. So let's see that how the graph is. Our graph is correct or not. So we have x minus 1. This is 4, I think so, and then after x is there, so this is x to the power 2, I think, and then x minus 1 is there. X minus 1 we have this is 4, then this is 2, x minus 1 is 1, and x minus 2 is 4, x minus
Sir, you have written x minus 1 2 times.
Okay, 4, this is plus here, and x minus 2 the power 4, and then after x minus 5, which have degree. See. Oh. So that means order. Oh God. See how it is. So actually, see what is it. See, this is or we can see how it will be. We can we can scale it lesser than. Let's multiply it here 0 minus 1. I just scale it down to see that. Even let me scale more. So see this is one scaling is there, no? The multiplication with the 0.01 is actually down, making a down. So see that I scaled it. So in here I didn't multiply it here 0 point something. There is no constant. But yeah, I just try to scale it. Means here is I make in our range. It is gives a very large and large number. So this multiplication just reduce it. So there is one thing, no? There is this an, or even let's say if I have a polynomial px, okay, we don't know what is polynomial, but if here is some number is there, no, it is actually just scale down of the polynomial. If it is suppose like this, if you multiply with the very large small number, so it will be like this. It will scale down with that, but the same, even the same root, okay, with the same root. Why it is happening? You are multiplying, you are actually dividing with the 100 each number, each coefficient. That's all happening. Otherwise, there is no difference. So it is actually scaled down that. Otherwise, there is no change in behavior. Exactly, it will be the same.
That means sir, altitude is becoming lower.
Yes. So now see that is we are correct or not. So see, this is the story. See at 5, see this is the S curve is, right? S shape is there. Okay. And at 2, we are went to negative side and then bounce back. So see that at 2, so this is -1, this is 0, this is 1, this is 2, this is 5. At bound we are bounced back, and at 1 we are linear. So let's see that at 1 how it is. You see this is at 1, it is linear. At 0 it is from above side and bounce back, the same. At -1 it is the same, and rest are coming to that side, means very large positive number you are getting, and then -1 we reaches as here. We just wrote like this, otherwise if we scale down a proper way it will be like this. Then this, and then exactly like this will go, not even the more wider form, very sharper form it will go, very fast. So actually our graph is correct, and we needed this one only. And number of turning point is actually we are getting 6 or 7, which is less than 14 minus 1, 13. So at most number of turning point is 13. It will not go, like, suppose you have a polynomial and degree of the polynomial is 14. So you will never say that the number of turning point is going to be 50, because it is going to be greater than 14 minus. So that's the mean here, turning point, the formula whatever we have just given, that it have at most number of turning point is less than as. So this is the all about, this is the see that how many concept we use it. Turning point, so there is not much of use the turning point, but in the behavior we use is multiplicity, roots we use is, and x-intercept, that multiplicity are different word, x-intercept. Even sometimes y-intercept is there. Y-intercept is nothing but, as you know, I just substitute x is equal to 0, you'll get output whatever that. At 0, whatever you are getting, that is y-intercept. There is one y-intercept, but so many x-intercepts is there. So always there will be one and only one y-intercept, and maybe more than one x-intercept. Okay. So these are the uses of end behavior. So main rule is of, you will see that it is multiplicity play a role, root play a role. Root is very important, and their multiplicity, and their multiplicity is decided actually it will be bounced back or back to in then same side, or linear, or S curve, or fluctuating. So very important role are, you can see the roots, end behavior, multiplicity. These three are very important.
Sir, if the polynomial is given in this form, we can find the roots. What if it is not in this form? Like
now,
if
so
it is,
suppose the polynomial is not given, so that's why in the next session we'll see that how we'll factorize. See, without factorizing, it is a very difficult to know the roots.
That's right, sir.
So you have to factorize.
So if it is like a 2-degree polynomial, we can factorize it. But
2 degree,
I don't-
3 degree, till 3 degree, on 3 degree is tougher. But 2 degree, if it is 2 degree, we are easily factorized. But for the
Yeah.
3 degree, it is now we need to know some other lectures. For that, we'll see it on Sunday. Okay? But it's enough to till here. Now I think only graphing polynomial is there. Oh, so I didn't tell you how to find the roots. So, okay, we'll see it. How we'll see the roots. The finding the root is not see. It's a, that's why you cannot always find the roots. It's difficult. But last time we actually did something, no, that hit and trial method. That
Yeah, hit and trial we can try, sir. So
and
if it is like large degrees, like 5 degrees, 6 degrees,
or
maybe
if
even
it is a
large.
10 degree, no, there is no issue. See, if it is a 10 degree, so once you know that, okay, the better thing is, actually we can quickly revise also. See, suppose you have a polynomial. No? Suppose you have a polynomial, that bigger expression is given. So what you will do, you will take the last term, let's say this is 5, without the x is there. Suppose there is 5. So factorize that, you can 1 5, you can write like this, 5 is kind of 1 5, or factors you can find of 5. which is 1 or 5. So plus minus 5 and plus minus 1 you have to check. Once you substitute here, suppose 1 is give the 0 here, or even let's say minus 1 give the 0. Once you substitute, you will get in polynomial as the output 0. That means minus 1 is a root. Sorry, yeah, minus 1 is as a root. That means x plus 1 is actually divide that polynomial. Right? So what you can do, then anyhow you have to make as a common. So one thing we can do, like, then exactly take the x plus 1, divide the polynomial with that. The quotient you will get. Again, whatever the quotient you will get, because remainder is 0, no? So as x plus x minus 1 is the root.
Factorize the quotient again.
So again factorize the quotient. Again use the hit and trial method. Okay? So that polynomial can be now converted as a x plus 1 and the quotient. Okay? Again do the same, try hit and trial, or if it is a 2-degree polynomial, then easily we can do. But it is more than that, then hit and trial, again take the last term and again do that. Again you will get some number. Let's say again you got x plus 1. And then it will become x plus 1 whole square. Some percent, again the some different percent you will get. Again do the same. The repetitive things you have to repeat. You have to think the same repeat.
But that's going to take a lot of time, no, sir. Do we get such time in exams and all? I mean, I don't know.
So no. So the thing is now, then in that cases you will maybe get some information. Say, then the question will contain some information. What is the information you will get? You have a polynomial. Okay, that expression is given. So and some information in the wording it is written. Some information is given that qx divides that given, or qx give. Once you divide qx, you will get the remainder like this. Or qx could be written as a 2-degree polynomial and then say that it's divide qx. Some information surely will given, and using those information, you will try to factorize that. Easily can be factorized. This information would be given. Without then, say, for it's totally difficult without these information.
Yeah, exactly.
But if it is
even
given,
3 degree is difficult, I think.
So this is all about for today's session.
So will there be questions to draw the graph for the polynomial?
Yeah, there could be.
Maybe they will ask about the end behavior.
Even in behavior, or even exactly the polynomial. The polynomials maybe using this information, and some 4 option will be given. Then in that graphs is given. Okay. Some graphs is given.
They can ask the number of turning points.
I mean, yeah, using those you have how many turning points they have, how many roots are there. Using these all information, you need to factorize. You need to know the roots. Okay, after knowing these all, easily can see the here is the roots. Some graph have exactly don't have the roots, or it will be in upside or downside. So exactly it will you need to decide using the end behavior. So that's why I use this end behavior. How will come to this side, upside, downside. These all information actually will you decide the graph in a small range. Surely some information is given. You need to factorize, or even in the factorized form it may given, as here I used. It's totally based on question, but it is not exactly, it may take lots of time to think that how the roots will get.
Okay, sir.
Okay, so this is all about. Thank you so much for joining. Anyone have doubt, we can discuss that quickly and we'll stop the session. Okay.
Sir, how many topics are remaining after that?
I think only the factorizing. Let me see.
Okay, sir.
Only one lecture is remaining. Graphing, so even this one I have discussed. Almost I have discussed. The graphing is also done. That's why one turning point is done. In behavior we done. X-intercept on roots is we have done that, and multiplicity we done. The same X and intercept is the same. Zeros we done. Yeah, nothing is remain. Division we already did. Addition, multiplication, polynomial definition, smoothness, degree, everything is done. In next lecture, maybe we'll see some questions, doubts. We'll see it. Okay. Next.
So can you go to activity 4.2?
4.2. Decreased. So I don't know. I have sent an announcement to get that to solve some practice. So all of you gone through that?
Yes, so thank you for that. Actually, I actually last open session I raised that issue. That,
yeah. So that's the thing is the mock is already we have to practice similar thing, and also week 4 related question because it's missing that. So that's why this is in already in your solution of practice assignment. Okay, but I just given the link with the announcement also. You can directly jump to there.
Yeah, thank
so
you.
If you see that it is contains the whatever you needed to do more practice. See, this question is totally on that, and also some other questions we contain.
Sir, we want some square error questions of different types because the questions are some different also.
So it may differ, but it is not in this. I think some square error is there also.
No. So in week 3 and week 2, because in the mock it was, I think it was different. What I have learned.
Yeah, the sum square is, but you see that the definition is exactly same. Okay, the definition is exactly the same as the
equation is totally different.
Yes.
So can you provide these types of sum, because in the exam it's just mind blow off.
Yeah,
I don't understand what it is asking.
That's why the mock is given, no? So know that the similar thing is happen, but no, it will not go beyond of it. Okay, don't worry that the whatever the mock we contain, no, it is that SSC is in the quadratic form we got, right? In the quadratic, and using that you have to got the minimum value. So that is the one thing, but it is not going to be much tougher example. Okay, so just if you know the concept, no, easily can. So don't worry.
Okay, well, thank you.
Okay, see, if it is like choosing the question we'll give, then it will take for me it's lots of time. But see, I thought maybe because we missing part from our side that question is not exactly with the turning or in the behavior, so that's why I just given. Otherwise, that is a mock, and so such type those type of problem. Once you know that, then you have to think you can create yourself some question and think that, or even you can search on SSC on the Google also and find that how will the SSC problem. Search on Google and see that how it is.
Okay, sir, we will do it. Thank you.
And yeah, I just given also for the live sessions if somebody is missing with the calendar, so that's why I just provided. Okay, this is all about. Thank you so much for joining.
Thank you, sir.
Activity 4.2.
Oh, okay. The last one. So who wants to leave can leave. Will the last doubt we'll discuss and close this. Okay. Which question number?
So question second. So here it's root 2. That means 2 has power of half. So will this be a polynomial?
Yes, it is a polynomial, and see that you need to here is the root, no? This is the root.
Yes, sir. Yes, sir.
Yeah, so this is see if you see the definition tells you the degree of the variable, not should be it should be a natural number, but here is not degree of variable. This is a constant, no? A constant can be any real number. So root 2 is a real number. Here is one thing. So you need to this one is you have to rearrange, or that means you have to solve that. Once you solve, you will get the degree 4. But this is not a problem. This is a constant. And if you see the definition tells you that the degree of the variable, it should be natural number.
Okay.
Okay. So thank you so much. Thank you so much for joining. Have a nice day. Hope most of the doubt have cleared. We'll
Thank you, sir.
see. The TA sessions
One
are
doubt.
there.
Can I
Yes.
ask one doubt? Yeah.
Okay.
It's been in one of the quiz questions actually. You have given a graph,
Okay.
which is f of x, g of x, and h of x of degrees 4, 4, and 2 respectively on the xy plane.
Okay.
Let f of x minus g of x is equal to ax minus 2, x minus 5, and x minus 10. A is not 0. If
Yes.
b is a negative constant, then
Hmm.
choose the most possible expressions for h of x
And some
other
graph.
correct state.
Yeah.
they are-
And some graph is given.
Yes.
No?
Actually,
Huh.
from the graph, we can see these two curves, that is the f of x and g of x are intersecting at some points.
Yes.
So I hope that f of x and minus g of x is the if you solve that f of x minus g of x equal to 0, then we can get those intersection points.
Intersection point. Yes.
But
Yes.
how to find this h of x actually?
So no,
The
once
other
you
one
find
you have
once
given.
you find the f of x minus g of x, so once you do that, you will, whatever the expression you will get, that is you need to factorize those all and exactly find the once you factorize them, that means though at those points it give the 0. That means at those point is going to be intersect. That, or even you can say at those points the value is the same. So let
The
me drive
intercept
this.
points I could understand, but there are three functions, f of x, g of x, and h of x. So there are three graphs given actually. One of the graphs is that h of x, it looks like as a parabola.
Yes.
So we need to find the formula for that h of x, expression for the h of x.
That require that this quadratic.
Yes,
Parabola.
quadratic. Yes.
So that means it will surely some information is given at which point it is passed through. So surely if you see that it is given that in that range, some range is given, and from the intersection point it is passing through. So you need to find the intersection point, okay? And once you find the intersection point in that range, and using that it is passes through. See that this is the graph. So once you find the intersection point, that means exactly you will find the output. And if you have a polynomial, so quadratic is there, so bx plus c. If you substitute one by one in that, if you substitute one by one in that, it will form you will get a two equation. You need to solve that two equation.
Okay. Okay.
Okay.
Okay. Thank you.
Okay. So now let's stop the session. Okay. And your doubts, today we have also session of TS. Please join those TS session. TS will try to resolve your doubts. I'm also trying to resolve your doubts. Okay. So you can ask in their question discourse in discussion forum. Yeah. Yes.
Sir, they are informing sometimes on WhatsApp and sometimes they are not informing.
What information?
Sir, they are telling class timings and sending links, sir.
Who?
IIT Madras online course, sir.
No,
Some number
there
is
is
coming.
no group. So there is, I will not say the groups. I will say is the IIT Madras group. The better is always follow with the I'm
calendar.
Calendar.
Sir,
Only
is not
better
a
is
group,
always
sir.
follow with the calendar or even that live session, whatever just now I said. This is the date fixed. This is the fixed date. Then even not even single session will miss out. If no one is there, you can exactly complain to this discourse. And I used to see that if TA is missing any session, no, you can write in the discourse or Google group. I used to watch there, okay, and also I'm usually asked to the TS how was the session, okay. So if they are not taking, I will get information that they are not taking or it is not happening, and you can post to in discourse. It's totally your responsibility, okay. Even if you are not getting into the sessions, post in the discourse so that I can know, so that I know that you are not able to win. I will ask to the TS, is there an issue happening? A technical glitch is there. So they will tell you, sir, these things happen. So don't worry.
Okay, sir.
And these are the fixed days. Okay. Each day we
Yes.
have session and PS will surely present there. Okay.
Yes, sir. Sir, but is there any official number for IIT? Every day I'm getting messages.
No, there is no such group. I don't think so.
No, sir,
From
not a group.
maths side is there is no. If it is there, then I would be there, but I'm not joining any group.
No, sir, not a group, sir. A number is sending programmed messages.
Programmed messages means what?
Means they are telling that today these classes are there at these times, and these are the links for the classes.
Oh, I don't think so. There is such, maybe some student is there doing. I don't think there is a group for maths, for online degree, for all this. I don't think.
Okay,
Better
sir.
to go with this one, okay? Better to go with the open this one and go. This is the fixed time, okay? And each day we have fixed days and fixed link is given, and surely PS will present there, or if it is instructor session, then instructor will be present.
Yes.
Please wait at least 15 minutes. If it is no one is there, wait 15 minutes. Within 15 minutes, you will reach. Somebody will be there. See, never
Okay.
it is happen. In 2-3 minutes, we used to present there. Yeah.
Sir, will the week 5 contents will be released today?
Yes.
Or will there be a break
No.
for preparing
No,
for this?
no. Week 5 content will release. Week 7, week 6 content will release as on the
So
day.
will there be deadline to submit the assignments of week 5?
Yes. So we'll see that how the deadline. After us looking to that corner side, we'll get that what is the deadline for graded assignment week 5, week 6. Okay. So dates or graded assignments will continue. So who will pass, will give the exam, who will pass, will continue with the maths. Wants to continue, can continue with the maths or next term. It's totally. I think all of you will have already gone through the procedures, how it is enrolling to the course once you pass. Okay. That's why it is a continuous thing. See, some other student which is already enrolled in this course, for those student, the portal is running. So it will be continue. Who will pass will enroll in this course and pass the whole course. Okay. So that's all. Thank you so much for
Thank
joining.
you, sir.
Have a nice day to all of you.
Thank you, sir. Same to you.
Thank you, sir. Thank you so much.